cancel it a bit. So it focuses by distance.
Oh, there was a really good, if you come back, counterclockwise towards me, a really good layers angle that you have right about here.
Tell you what, why don't I?
Like right in the transition from light to shadow. Alright, let's see if we can zoom in more. Oh. See if we can max our zoom. And then more light. Oh, the underside. You can get the underside in focus.
There, the front is in focus now. I just need light.
Let's reduce this a bit.
You're probably gonna have to wash your hands because it's super greasy.
Okay.
Like, we got serious shaking going on. There we go. Yeah, oh, that's money. Oh, yeah, that was really good. If you can come just a little bit more angled. Yeah, there.
I have like that psychedelic.
It's got a rainbow thing
The
going on.
rainbow thing, yeah, that's the that's
I
what
wanna-
bismuth does.
I want to nudge the focus. Not sure if it's your way or my way, we'll find out. No, it's back.
Kinky.
Did we get enough pictures yet?
No.
Here, I'm gonna leave this here. I gotta go take it.
Yeah, do your thing.
So just
We'll make sure it's safe.
yeah.
Mark, what is the recipe for the alien blood? So I can make some more?
So
Alien salad?
Alien blood.
Like this position.
I'm trying to put something there for a size reference.
Oh, my phone's here.
there's gloves over here.
Where?
Let me get there. You do have to handle it with your hands.
I do not want to touch this with my fingers. We're
There.
contaminated.
Where's there?
Oh, those are special shoes for the cleaner.
Okay.
Is this another alien piece?
This is the same one. It's just I'm trying to. You've probably already taken at least 150 photos. But now I have this new here as a size reference. And maybe I should do like the size of the cup.
Should we do the standard quarter in the photo?
But you got a dime? Can you find me a dime? Or a penny. Dime or a penny.
Huh? What's the dime or penny?
Eric is getting me a coin for size reference photos.
More than you would do anything for
So
myself.
yeah, that'll pick. Right. keep calm.
Hey Jared, I'm gonna go to lunch. Do you want to come or?
I'm good.
Too excited.
Very good. Oh, okay. But thank you for asking. I just learned about themselves.
you're basically just going to stay right there for like the next week of time.
Maybe.
Mm-hmm. Can you blame me?
Hmm?
Can you blame me?
No, probably not. While I am still recording, what are your initial reactions so far?
Outside of this, the rest of this, I gotta forget about today and think about all days other than today.
No, I mean, what are your initial reactions to the what are the metal?
Oh, to this.
Yeah.
We are talking about this. Like you can totally see the layering in there. There's some translucence, like you get some rainbowing from certain angles. It also looks like there's copper in there.
I mean, it does look like it looks like that multiple layer. It looks like Earth's parts to me.
It does.
You have to kind of look close, but you can see the layers, the striations. Also, the jagged edges from where it was broken. That also reminds me of Earth's parts.
Like that, other than like this one having just one really dark line in the middle there, you know? I mean,
Yeah.
this one has like lines in it, and especially from certain angles. When I get this thing set just so.
This is a much smaller piece. That
Yeah.
one is next to a quarter. This is on a penny.
Are we sure that's a quarter and not a penny?
It's a quarter because the ribs on the.
Oh, yeah. Could be a dime.
Yeah, it might be.
This right here is what I want from Michael,
Yeah, that's yes and no.
right? Because these layers are kind of the thing that everybody has been saying is related to it being as a waveguide. And then in this book even, they talk about the tests they ran where they got some anomalous things when they ran terahertz on it.
So how do you feel? This is your first piece of real UFO wreckage.
When I look at this thing and I let my imagination go that this is indeed from a, whether terrestrial or extra or ultra, I don't care what kind of ship this came from, just the fact that this came from a ship that had a non-zero chance of not being made by people in the 40s, right? Because right now, according to Linda's book, if this is indeed one of the 6 pieces of Art's parts, those 6 pieces came from either the Roswell crash site, which it seems like is the most likely, or potentially the Horse Falls site. In either case, it's a crash from the 40s to the 60s. And it seems very unlikely, especially when you look at these isotope ratios.
So does that make any of the stories more real for you, or
much more real? Like, there's already a pretty good amount of evidence out there that the Roswell thing happened. There's enough, others have gone before me and done all their due diligence on that story. There's a lot there. But to have an actual piece sitting in front of you takes it from being just a story to being, this is actually part of, our reality that is unacknowledged.
Mm-hmm. Well, the reason I ask that is because I think all of us are messed up with 75 years of cultural programming, right? Movies,
Yeah.
TV, comic books,
Yup.
stickers,
There.
Yeah, I mean, to me it certainly resembles both in terms of the jagged edges, the way that it seems to be sheared straight through, but in a very jagged way, and then the layers. That, to me, it seems very, very reminiscent. In fact, the way that you had the camera set up wasn't to the size; it almost could have been that other sample. So,
And like here, you can kind of see some of those dark lines in between the flashes of this cheap microscope, USB microscope.
Well, let me. Oh.
well, I think you guys have made a historic discovery. You know,
Absolutely.
I mean, others have had that before you, but I think the point is that you have rediscovered it, and you're in a position and you have the interest and the knowledge to be able to analyze it, right? So,
Yeah, if we're lucky and we can get the testing done on the sample that we think we have the ability to do, some new scanning electron, because this is 1996 was the last time we got SEM of one of these samples, and the technology has improved significantly since then.
yeah.
This is an isotope ratio on screen now, but
Well, and again, I believe with Gary Nolan, and I think he was testing the Utah crash, but he had to use destructive testing, I believe.
yeah,
So he had to actually vaporize it and look for the compounds. But that was how he was able to come to his determination that there were isotopes that weren't found on Earth, right? So
yep. And then here's the side by side.
yeah. See, and you can see it's a jagged edge, which is really interesting, and it's
You can see the dark.
there are definitely layers.
So the dark line layer here, you can see it's relatively near the middle, just below middle on that one. On this one, it's relatively close to the middle there.
I've heard a few different hypotheses. One of them could be, and I think this comes from Mark, that the layers inside of this could be a waveguide inside the skin of the craft. And so it would allow the whatever field it's using to either completely surround the craft or maybe even it out or something along those lines. Another theory has been that it's some kind of capacitor, which is probably unlikely because I think zinc and magnesium are both conductive. But
So the zinc and magnesium, when you take the zinc and magnesium, that's a way of storing electrical charge as like a capacitor battery.
okay,
But the bismuth thing is special because it's got some really interesting qualities. One thing is it has a really high thermal conductivity. So if you were going to use it to like conduct heat up to its low melting point, it would conduct that heat very well. It's also potentially useful for converting heat into electricity. So when you layer bismuth in between these conductive surfaces that are able to store a charge difference between them, it might be that it was using, the heat of the atmosphere against the hull to generate electricity. The more likely thing, though, is that bismuth happens to have one of the highest negative susceptibilities of any material, which means that when you apply a magnetic field to it, it repels against that magnetic field. In the book here, Winter Molten Howe's Glimpses of Other Realities book, they talk about the terahertz testing that they were doing on it. I'm currently looking for that. Terahertz.
do you think it could be structural in nature? You've got
It's so brittle.
Okay.
It's very brittle. That's why I'm using like these needle tips to kind of very carefully adjust it, because it's like a potato chip.
Okay.
You don't want to chip off any of it. So for it to be in the outermost hole of the craft and have this kind of structure to it tells me that it's probably used more as a energy conversion for heat on the hull of the craft into electrical energy, or it's used for the lifting mechanism where it has a 1 to 4 terahertz window for the thickness between the layers, makes it a waveguide for 1 to 4 terahertz wavelengths, which, from what I've seen about a lot of the different ways that these craft seem to operate, they seem to use this higher order resonance effect. So you start with a lower frequency and then you use that to vibrate something that happens to have a much higher resonant frequency. So you make a couple hundred hertz thing that vibrates a couple megahertz thing that vibrates a couple gigahertz thing, and that vibrates a couple terahertz thing.
Okay.
So 1 to 4 terahertz is in the deep infrared, which infrared is heat. So it anytime that they can do multiple things, right, when a single thing can have multiple uses, that's very efficient. And if there's one thing about these craft that it seems like there is, even though we see a ton of energy coming off these craft, Kevin Canoes has calculated how many hundreds of megawatts of energy,
Yeah.
right? The Barbell MUFON K74282, that one, 160 megawatts of energy is coming off that thing.
Now, would you assume that there's good heat resistance with this or not?
No, because even though it's got magnesium, which has a fairly decent high melting point, and aluminum has a fairly decently high melting point, the bismuth layer has a really bad melting point, right?
Okay.
So you're looking at melting points of like 3,000 for magnesium, 1,600 for aluminum, and like 500 or 600 for bismuth.
Well, and the reason I ask is, so if this was on the skin of some kind of a vehicle, then you could assume that the vehicle wasn't exposed to large amounts of heat, right? Otherwise, this would be destroyed.
Yeah, well, that's what Mark was saying, was that this dark side versus the light side that I just had earlier, that's what happened to it after it had crashed. So before it crashed, it didn't have a dark side.
Yeah.
It only had light sides. But after that crash, it got all this oxidation from all the flames or whatever else was going on with the heat after it had impacted. So rather than looking at this dark side like, a re-entry burn on a craft, it's more likely that that's, entry into the ground burn on the thing.
See, it has a crystal structure on top, doesn't it? It has, what are those? It almost looks like a honeycomb. And it almost looks regularly spaced. Look at that.
So there's other pictures out there. I'll have to find them, but
You
yeah.
should do a screenshot of this one. What's the button for it?
Oh, I'm taking pictures here.
Yeah, if you can get it just right, you get the, because
There's a honeycomb there. There's a honeycomb there. There's a honeycomb there.
Yeah, so the skin has honeycomb dimples on it. Look at that. And it only shows up. Yeah, try and get
At the right angle. So maybe if I lower the angle more, I can get those shadows right.
There you go. Look at that. Now maybe the honeycomb is for structural reinforcement.
Or Grebennikov talks about the cavity structure effect, CSE, and he was all about how honeycombs are like these ideal resonators for certain wavelengths that somehow relate to repulsive forces.
Yeah, so look at that. You've made a new discovery about Earth's parts.
Potentially, yeah. I want to flip it back over and look at the other side again and see if we can see similar, because I don't think it's got that on the other side. Okay. That was your observation of the honeycomb. I wasn't even noticing that. Yeah, the other side is... This is the side that got both sides got super hot. This kind of looks like it got hot enough to start bubbling.
Yeah, it does. It looks like it's bubbling.
Right? That looks like what volcanic rocks look like.
But it looks like it bubbled up in a honeycomb. It looks like it bubbled up from a honeycomb structure, doesn't it? See, you can still see, yeah, you can still see what looks like the outlines of a honeycomb, but they're deformed, sort of.
Let's see if I can zoom in on that a little more. It'll help us identify that honeycombing.
Look at that. What are the crystals on top? Look. Where's
You do the taking pictures. It's that.
Okay, try and hold it like that.
So yeah, when you say that you see the honeycomb pattern, where I see it is this dark line around here, and especially because you see this 120 angle right here. That 120 angle is a hallmark of the hexagonal structure.
Can you try flipping it over again now that it's magnified that?
Yeah,
Can you magnify it even more?
I can. Oh, take that picture.
You're missing it.
Yeah, I want it darker. I want it darker. Take it.
It's
I know. But what I'm getting at is there's certain angles where you can see this hexagon. Kind of looks circular.
Okay. Try and flip it, or try and magnify a little more.
I need something to put this down.
There you go. There you go. Hold on. Oh, and you can see the striations on top.
Oh, I just found another honeycomb on it. That honeycomb. Oh, I see these that you have.
Oh, the button changed. The button went away. Do you want to try to flip it over again?
Let me take a couple more of this angle, and then yeah, if you could take pictures. You're gonna get out of the shadow there. There we go. No such thing as too many pictures. Wait, take that picture. I noticed that I see like some turquoise there.
Yeah, I see little turquoise spots too.
Okay, now I'll flip it over. See if we can get the focus a little better. Focus just on getting you good light first. That's the loud focus. That's not really clever. Look at all those multicolors there. Oh my goodness. I can't help but wonder if all these different colors we see are like related to the different colors that people see UFOs light up like. Like maybe it's all those little things are getting fluoresced.
It does look like it's fluorescent, doesn't it?
Right? Let me take a little video of that.
Yeah, look at that. Interesting.
Like it has this weird refraction going on. What is this thing doing with light? Like, all up in here, when I move it around, it's like it's reflective, but it's like it's melting the light together.
It looks like one of the layers, or maybe more of the layers, is partially transparent.
Yeah.
And so you're seeing refraction through one or more layers. That's what it looks like to me. You know, like gasoline on water, right? You get kind of it splits the light, but you're also seeing a reflection from layers below it. Because when you move the light, the reflections change, but it looks like you have a couple of different layers that they change on, right?
Yep. I think I might be able to even get it zoomed in just a little bit more because I would love to see this refraction. Keep that light on it while I do this. You gotta get the light in underneath it at an angle there. Wow, I really lost focus. Like, it's out of focus.
I think you need to move it maybe up just a little bit, maybe focus in,
Yeah.
because it's enlarging it too much. Yeah.
I want to get more zoomed in than that. And
That might be as good as it gets.
yeah.
There you go. I think that's. Oh, look at that. Look at that. What's the pulsing?
That's the light. That's the camera has like an auto brightness thing,
Oh,
and it's
okay.
fighting. It's fighting this But there is definitely some crystal something going on with this.
Okay, I'm repositioning my camera a little bit.
Oh, you know what it is? So it seems like that reflective tape stuff that you find all over the place. It reflects light back to the source. I zoom out and see if I can capture this reflection thing again.
Santa Claus is coming.
We found some good stuff.
Town.
So,
Oh, cool! You put it on Penny.
Yeah, so a couple of things we found. Let me stop the recording. A couple of things we found. Hexagonal structure on it. I've also found that it's got some weird reflection, like reflective tape stuff. So watch this for the reflection.
Ooh, look at that.
So I just zoomed it out. I might need to zoom it back in to be able to see it.
So on the screen behind us, we have two images of metal samples. The first on the right is known as ART's parts, right? It's a reportedly UFO crash wreckage that was sent to radio show host Art Bell in the late 1990s, I believe. The second on the left is a screenshot that you took from a microscope today.
Correct, yeah. This picture right here is inside here, and it is a very small sample. It is about 2 millimeters this way and about 4 millimeters this way, so very, very small.
You've been going through this, now this is just visual observations, but you've been going through this thing for like 3 or 4 hours now. I mean, what are you seeing so far? It looks like it has, this is what I've noticed, the jagged edges, again, the History Channel image on the right, that shows jagged images, and it also shows layers of material. The one on the left looks like it has pretty much the same thing, right?
It does, and about the same thicknesses too. The thicknesses of each of these layers is pretty similar to the thicknesses we observe in this one. Now this piece here is much larger. This piece, if I zoom out a little bit, so they don't have it in this picture, but a regular American quarter fits about that big around it. So this piece is actually relatively large, and this one is probably just a flake off of the end of it. But on that flake, we still have this stratification on there. Some of the things that I've observed in this stratification have just been blowing me away. Under different lights and different angles with different wavelengths of light, there's these little streaks of different colors inside there. some of these colors suggest like copper deposits. Others suggest there's these little speckles all over the place that kind of look like nanospheres that are capturing very specific wavelengths of light. And even cooler, there's streaks where you have all of these nanospheres arranged in kind of like a weird lattice pattern that doesn't just follow these stratifications, but it actually goes diagonally through it and it crosses over. And you have all these different sizes of nanospheres in there. So you have all these different colors. So it sparkles like a rainbow. You get all the same colors from these nanospheres that you see in UFOs all the time, where they'll do these color oscillations of red to green to blue and violet, and then go back to red. We see all of those same colors present in all of these little sparkling nanospheres apparently in here.
In terms of these samples, one of the things that I noticed, we put this under a variety of different light, right, to look at the shadows on the surface. It appears very different, not surprisingly, it's just a little piece of metal. It appears different under different lighting. One of the things that it looked like it had was some kind of a hexagon structure on top.
On both top and bottom. So on both sides of this sample, you can kind of see one of the bumps here where it's a pushed out hexagon. But if I scroll through some of these pictures, I might be able to bring up some of those hexagons we're talking about.
So you have done about 230 screenshots so far. So there's a lot of screenshots there.
I'm almost there, I think. A lot of screenshots.
Yeah, you've been very diligent.
Here we go. So on here I can start showing it. This one's a little grainy. I think I have some zoomed in ones here. You can see these ridges on here, and at first glance, it just kind of looks like pock marks. But you start looking at it closer, and you can see all these 120-degree angles that are reminiscent of hexagons. So up here, you kind of have these three 120-degree angles coming together around this here, which suggests that there's a hexagon on either side of this. Down here on this one, you also have these 6 sides. If I keep on scrolling through the images, on the other side where you have this bubbling, you also have these 120-degree angles showing up in the bubbling patterns too. 120 there, 120 there. And so it seems like each of these bubbles is actually a hexagon that's been deformed. If I keep going through here, I get higher and higher quality. So these hexagons, they seem like they're different sizes too. Different hexagons to capture different wavelengths or something.
Okay.
Here we go. Now I'm starting to get into the high quality ones. You can really see those 120-degree angles that are all over the place, showing that this is indeed a regular structure.
And when we are ready to release this, what I will do is put up the screenshots so that people can look at those themselves.
Excellent.
You know, this is 4K video, but it's going to be kind of small, right? And it'll be difficult to tell. So
Yep.
what we'll do is put up a link to a photo gallery so that people can go through and just take a look and see, you know, what's there. So one of the things that I'm seeing in this photo, and again, this may not show up on camera, is there's some iridescence, right? You've got what appear to be different color reflections from this.
So these turquoise colored spots, they show up really nice on the microscope. And those kind of remind me of copper. And you can actually follow along, and there's these streaks of them. Like, it's not just a single speckle. You'll get kind of these lines of them. And when you look at it edge on, you'll see it crosses through the layers at an angle, which suggests there's some kind of, once again, regular pattern to these things. It's not accidental.
Now, so one thing I should mention, and again, we've got the history sample on the right, and you know the arts parts, the official arts parts on the right, and our sliver on the left. The difference between these two, I think one of the reasons we're seeing hexagonal patterns, one of the reasons we're seeing iridescence is this is a much smaller sample, and so we've magnified the heck out of it. And so in the arts parts sample that everyone has seen and is familiar with, again, you're saying that's comparable to a quarter. This thing easily fits onto, like, I mean, this is just a tiny part of a penny that it
Yeah,
fits onto.
you
So-
can see the ridge of the penny here. In some of these photos, I actually have the number from the year of the penny, which kind of gives a better idea for the size.
Yeah, there we go.
There we
Yeah.
go. So you can see the 2017 of the penny, and you can see this thing is just about as big as that. And a penny is not very large, right?
Yeah. So one thing I should mention also for anybody who watches this in the future is this is not really something we were prepared for. We were actually doing filming and testing on Alciphon dynamic nuclear polarization propulsion mechanisms. So if we're not real organized, that is why. This just kind of fell into our laps, so to speak. But it is exciting. This is really exciting. So from what you've seen, I mean, does this seem like an anomalous material? I know it's difficult to tell just looking at a tiny little sliver.
So I've tested it for magnetic response. It does not seem to be attracted to a magnet. I've yet to have a spinning magnet near it to see if it has a diamagnetic response or not. I'm a little scared too because it's a very small, fragile piece that would be easy to lose. We have hopefully the opportunity to get some electron microscopy done on it here pretty soon, and I suspect that'll tell us a lot because in Linda Moulton Howe's book, Glimpses of Other Realities, which I have up here, you can see, if I scroll up just a little bit more, you can see in the electron scan these micron thick layers where you have these different materials that are fluorescing.
So let me ask what those materials were. I believe there was bismuth and magnesium, right?
Yes, so something that is very easy to miss about this stuff is you have two sides of this, right? You have one side that is kind of shiny, and there we go. So that's kind of a shiny side, but if we go back to where I have it flipped over, this indented one is very, very dark, right? That's very, very dark compared to the other side. I think I can flip it back over here. There we go. So here's the difference between the two sides. You can see one side is very light and reflective, and the other side is very dark. In Linda's case, the test that they did, this dark side here is almost pure bismuth. And this light side here is almost pure magnesium.
Okay.
But inside the layers, the stratifications of this, that's where you get the layers of magnesium, zinc, and bismuth. And the zinc is very small amounts. And the bismuth is these imperceptibly thin, dark lines, which at the beginning of this, you could see in those layers, those dark stratifications you see are the bismuth lines. So in this sample that we have, comparing it to the sample from Linda's book and the experiments that they did, it seems like there's an overwhelming similarity between the two. From the small amount of tests that we've been able to do so far in the last couple of hours, there are many things about this which are not mentioned in Linda's material. Linda never mentions that this thing might have had hexagonal structuring. I don't think they noticed that. You yourself were the one that pointed that out. The iridescent nature of it, yet again, not something that has been pointed out before. For me, the thing that I'm most excited about is the different colored tiny speckles that you see at different angles of this thing.
Now, do you think that those could just be crystals on the surface?
I think they're deeper than that because when you look at the side, the cut side of it, you see those colors show up as well. So those colors go all the way through the material.
Well, so one of the things that's interesting to me, and I'm not sure how to describe the cuts, but they look like ridges. They go from top to bottom. And that's really intriguing. So I've seen landscapes that do that, right? Like I lived in Arizona for a year and you see that.
Like the basalt.
Yeah, like basalt at the edge of a plateau, right? Where the plateau ends, you'll see those columns and they're like ridge-like columns. And that's incredibly intriguing. Also, what's even more intriguing is to see that on this smaller piece as well as on that original or its parts piece. Mm-hmm. And those columns run, they're perpendicular to the layering, right? Which is even more intriguing. So the layers kind of go right through it, but it breaks off in columns.
Yes, I can't help but wonder if there is microstructure within the larger structure. So the larger structure are these hexagonal cells, and then within those, they're probably made of a fractal-like smaller hexagonal cells.
Yeah.
So you have this basalt-like, column-esque type thing going vertically, and then those fit together to make larger hexagons. And if I had to guess, probably this cell of all these hexagons probably fits into a larger hexagon. It seems like this is a recurring theme over and over with this kind of technology, is having the very large and the very small be copies of each other like a fractal. Same goes for the frequencies that it seems like show up. You have very low frequencies going up to medium frequencies to high frequencies, and they're all harmonics of each other. And it's this overarching idea of the very small fitting together to create the very large and being similar all along the way.
I think the supporting idea behind microstructures then is the layering runs horizontally, but these breaks in the columns run vertically, and it appears that they're breaking across some kind of invisible boundary, because they're not jagged, they're not breaking on the layer boundaries, they're breaking on something else. So there may be some kind of a structure inside of those. Now, speaking of structure, this is not a structural element for a vehicle, right?
Probably not. The fact that we have that dark underside made of bismuth, and we have these layers of bismuth in it, to me, just as an observation, it seems like this peeled off of another layer. This layering probably goes much deeper than just the bottom of the sample we have. It's probably part of a much thicker piece. And so as you take just these little flakes off of this much larger piece, I have to wonder, as light or RF or other kinds of fields pass through this material and have to go through all of these crazy lattice-like structures of these different colored nanospheres, if that somehow relates to the actual lifting mechanism. Because bismuth and magnesium and zinc like this, it's not very strong. It wants to separate. These layers don't like being next to each other. Some of the folks in this very lab have already tried to recreate this material in months past, and they found that it was extremely difficult to get these materials to bond together, because these materials do not like to make good bonds together, which for structural, you don't want something like that.
Okay, so these materials could potentially form a waveguide, right? The layers on these materials. And you could use that for, if you were applying fields to it, if you wanted the field to be homogeneous throughout the surface of the craft, you could use that as a waveguide for internal propagation, right?
Total internal reflection of these bismuth layers would allow, based off the measurements that have been made in the past and our renewed measurements, about 1 to 4 terahertz, very low infrared frequencies. But if indeed this recurring theme is also present here, where they take lower frequencies and upscale them to higher frequencies, it might be, just again, as an observation and a guess, it might be that they're using these bismuth layers to guide very low wavelengths of light into these nanospheres of much higher wavelengths of visible light, right? So you have 1 to 4 terahertz for the infrared, and then for the actual visible, you got hundreds of terahertz, right? So it almost seems like they are pumping low infrared through the bismuth layers, and then that energy is getting upconverted into higher frequencies into these nanospheres, which probably again upconverts even higher yet again into gamma rays.
Now, another aspect of the layers that potentially maybe could be there is some kind of capacitance between them. And a true capacitor is probably not as likely, because bismuth and magnesium are both conducting, right? But some kind of capacitive junction behind them, almost like a transistor, might be possible.
And zinc likes to oxidize. And when zinc is allowed to come in contact with air, it sucks in these oxygen molecules and gets this insulative layer over it. As soon as you have a zinc oxide and magnesium together, you have yourself a little capacitor, because you can store opposing charges on those thanks to that oxide layer. It turns out that bismuth is used for thermoelectric generation. When you put heat or infrared radiation through bismuth, it likes to convert that from phonons into photons, into actual electricity. if you were able to exchange the electricity gained from the thermal side of the bismuth into these surfaces of magnesium and zinc oxide, you might be able to generate extremely high charges because you have so much surface area with so many layerings. It's similar to a capacitor coil where you have this like winded coil of two kinds of metal around a piece of paper or a dielectric, and you're able to fit into a very small space a lot of surface area. They're doing a similar thing here, but instead of a coil, it's a bunch of layers.
From the inside of the craft out or from the outside in, you potentially have capacitive or transistor-like boundaries, right, as the layers are on top of each other. And side to side, you may have basically, I think you were saying, 1.4 gigahertz, something along that.
Terahertz.
1.4 terahertz traveling as a waveguide inside of those layers. So one of those is outside in, inside out, and the other one is basically along the boundary of this skin. You could potentially have two different effects going. Now, with these microspheres, that is something new. Again, that's just a visual observation. Are you able to confirm that at all, or is that something that's going to take more work?
I think to actually confirm that is going to require some X-ray diffraction, which that's been done on other parts. I think Gary Nolan did some of that, and some of the things that he observed was that there were dopants. He would find one atom of some really heavy element inside a substance like aluminum that's a fairly light element, right? And he would find one atom in a range of a couple thousand atoms, right? So it almost seemed, and he would find regularity between the placements of these. So in those samples that he has, whoever built those are showing that they have the ability to place a single atom with extreme precision where they desire within a lattice structure. It could be that that's happening here as well, but until we have that X-ray diffraction, we won't know.
Okay, that brings up the manufacturing process for this. So Falcon Space is involved with vapor deposition. Exodus Technologies, whom we are good friends with, they are involved with vapor deposition, right? And it is possible to lay down layers like this using a vapor dep system. Do you think that something like this could have been made with that?
I find it difficult to believe based upon how difficult it was for Falcon Space to try to get that layered system going. When they made their layered material, it consisted only of a few layers that were thicker than this, and those layers did not adhere well together. And I want to say, I wasn't a part of this, so this is all secondhand, but I want to say that they didn't get this similar, you know, one side is bismuth and the other side is magnesium, right? So they had the layering, but they didn't necessarily have a lot on one side and a lot of the other on the other side.
Well, and presumably this is part of a larger object, and I think that might run against the traditional vapor dep idea as well, because the machines that I've seen, it's a small machine, you have to put it in a holder, right? It's contained, like the containers, the holder that I saw was about the size of maybe a 3x5 card. The actual sample was much smaller than that, and you basically just vaporize, you know, different metals one at a time, and they deposit on the surface. So to do something the size of a craft or a vehicle, that doesn't seem practical to me.
That seems like a level of technology that is a long ways off.
Do you think something like this could be grown using nanotech?
I have no idea. That is not my jam. I don't really deal with nanotechnology too much. As far as the nanospheres thing, I've learned a little bit about those. And as best as I can tell, it seems like, in my opinion, they are, just based upon the sizes that we're observing and the wavelengths of light that we're observing from them, as well as the angles that that light has to be to make certain ones fluoresce and others not fluoresce.
So in terms of making something like this, and again, I am shooting from the hip. We've only had this sample for a few hours, so I'm just kind of going from memory. But if I remember correctly, this could have been Gary Nolan's sample or someone who looked at Art's parts. There was commentary I'd read that said that something like that could be manufactured, but it would be prohibitively expensive. Do you have that kind of, would you agree with that?
Yeah, so with reference to that, he was observing the isotopic ratios of this, of his samples. And when you have certain elements that are really common elements, sometimes those things will have an isotope that shows up like 0.1% of the time, right? So all of the magnesium on Earth, 98% of it is one isotope and 2% of it is this other one. And that 2% usually is the one that doesn't come from Earth. It comes from asteroids hitting Earth or something like that. It's stuff that's made elsewhere. And so he's observing samples that are made almost entirely of isotopes that come from asteroids or elsewhere. In this case, until we do the isotopic analysis of it, which is a destructive method, which is going to be really difficult since it's such a small sample, but until we can get that, we're not going to know for sure how much of this sample correlates to isotopes not normally found on Earth.
Oh, okay. So there's a lot more to do there. Now, another aspect I should ask about is if this comes from a vehicle hull, if it is used somehow in a propulsion mechanism, does that offer any insights into your own work?
Oh, absolutely. So the level of technology that could be present with this is far advanced on where we're currently at. Some of that technology involves, like I already said, thermo to electric conversion.
Okay.
It involves up conversion of certain wavelengths of light. So even though we have these terahertz waveguides, because now we see these potential nanospheres in here that are taking those low terahertz into much higher terahertz, it gives us an idea on maybe some potential methods on how we can up convert very low frequencies into very high frequencies, where you can do some really cool stuff like photon to phonon conversion, which is electric energy into thermal energy or even momentum energy. If you can control phonons and vibrations, you can have a way of creating thrust without necessarily having any moving parts.
Do you think that that could be used to dissipate heat from the hull during travel?
It could be used for multiple things simultaneously. It doesn't have to do a single function. And in fact, when we look at military aircraft, oftentimes things have multiple functions.
Yeah.
And that is for our current day technology. If you take something at this level of technology, it only makes sense that they're going to make sure that each part of the craft has multiple uses and is taking care of multiple functions simultaneously. So if this hull is able to dissipate heat at the same time that it's able to generate energy, at the same time that it might be able to generate thrust, that's an extremely efficient thing that is reminiscent of a highly advanced group.
Yeah. Well, the reason I ask about that, though, is I'm wondering if we can work this in reverse a little bit and tell a little bit more about the vehicle that this came from. If this, in fact, is skin material from some kind of UAP or UFO, right? Now, you've mentioned that it's brittle, for instance. And so what that says to me is that it may not get a lot of direct exposure to, things that might shatter it, right? Another one is like something that Dr. Sean Kirkpatrick and Avi Loeb talked about was this potential of fireballs as it's traveling at high speed through the atmosphere, right? That's not something that we see with UFOs. And so if this skin is delicate, as you're indicating, I wonder if it could be protected by a force field, right? Maybe we could kind of work this in reverse and make some educated guesses about how this vehicle might be operating, I guess.
If it's able to manipulate space-time around it, that's one way of creating a force field, because if you can slow time, that gives you time to react to things. So if you fire a bullet at a craft and that bullet is going 1,000 miles an hour, but that craft has a strong enough gravitational field in a very thin area that bullet relative to the craft now is only going a couple miles an hour, that gives the craft time to be able to respond by putting out an electromagnetic pulse that deflects that piece of metal that is now going at it at walking speed instead of ballistic speed.
So I guess the question is where it goes from here,
The very next steps are we need to do a couple of elemental analyses of these. We need to know what isotopes are present. We need to do X-ray diffraction so we can identify what potential lattice structures or quasi-crystalline structures are present in here, because Gary Nolan has observed those as well. You have aperiodic structures present in these. And then the last thing is we need to identify how thick each of these layers are so we can identify what frequencies of terahertz radiation is present being used within these bismuth layers as waveguides.
Okay.
If we can identify those three things, that gives us a lot of data moving forward on how we can engineer our own versions of these. Also, if we can identify the sizes and the wavelengths of each of the nanospheres, and especially their layout, which I think the X-ray diffraction would show, the quasi-crystalline nature of these nanospheres and their relationships and positions to the business layers. I think that is a whole area or completely new branch of study just waiting to happen.
Okay. Well, and I think it's so fortuitous that this fell into the hands of Falcon Space, right? Because you guys are working with UFO reverse engineering, number one. That is a focus area for this organization. But also, being a propulsion-focused organization, you're able to interpret this and into like functional form, right? As opposed to other people who look at this and say, okay, well, potentially it could be used here, but I'm not really sure. I don't know how this would fit with the vehicle. Falcon Space is able to look at this and say, okay, here's what we're working on. Here's how this could potentially fit. Here's where this could all go.
Correct. There is a lot of ways that this can end up going. There's a lot of avenues that we might be able to pursue right here at Falcon Space to make this technology that we have right in front of us realizable in the near-term future for the rest of humanity.
Okay, perfect. And you know what? I'll do a single camera shot. Here we go. I'll just put it right here. Okay.
There we go.
There. So now we can just BS. That's about as good as it gets for me. So
this shot looks like it shows, even though it's kind of grainy, it shows those vertical columns we were talking about.
okay, well let me back up just a sec. Let me run through. So again, this is what we believe is Art's parts.
Correct. We have been analyzing this for most of the day, and we have observed a lot of stuff about it. One of the things we observed earlier that I'm now getting a closer look at with a new lens on our microscope is on the edge where it broke. It seems like there's a certain pattern to that. It seems as though you get these ridges on there, which are similar to basalt ridges. You'll see those basalt cliffs sometimes near oceans where it has these regular hexagonal shaped vertical columns.
Okay.
So I am currently in the process of taking pictures of these
More
for
screenshots?
further analysis. Yeah.
Yeah. Well, and I'm just running the camera on this one. That way people can kind of see what's going on with it. So,
Let's see
again,
if
we
I
are
can
at
twist
Falcon
that.
Space Labs. This sample was given to Mark Sokol. And if we seem a little disorganized, that is because we have been doing dynamic nuclear polarization testing all week long. Careful that penny doesn't drop.
Yeah.
And so this is kind of the last thing we were expecting to come up.
This was a complete surprise. Didn't even know we had it. There we go. Let's try to adjust that focus. And then
So this does, again, this is a layered metamaterial, it looks like. And it does have the ridges you mentioned, like a basalt structure. Interestingly, the ridges go straight up and down against the layers. You'd suggested earlier that there might be some kind of other structure inside of this. We also thought that we saw some hexagonal structure from the top. Kind of hard to make out because of the shadows. And then one thing that we should point out is this sample is tiny compared to the larger Art's parts material.
yes, the larger Art's parts makes this look so minuscule. The larger one is the size of a couple of quarters next to each other. This one is barely about the same size as Lincoln's face on a penny.
Yeah. Yeah, that's important to point out because we're noticing structures, we're noticing details that weren't identified in Art's parts, but that's because we're magnifying it a lot more.
If I point this down, so right now I have it sitting on top of a penny. So that gives you an idea to the thickness of the sample that we're dealing with. Art's parts was a couple quarters thick. This thing is barely about half the thickness of a penny.
Yeah. Although that being said, when you put it, you put photos of Art's parts side by side with this, the structure and the layering appear almost identical. So.
Yeah, you get those dark bismuth lines there on the side. We're assuming it's bismuth. We haven't verified yet, but based on how similar it looks to the samples that we have pictures of online. And I'm just playing around with the flashlight, trying to find the right angles to get good pictures. And unfortunately, this USB microscope does have a limit where it flashes for its refresh. So we're doing the best we can with what we got. And we're gonna have better equipment here to test this soon, now that we know that we need to have that better equipment. Because like you said earlier, we weren't even planning on having this.
Although to be honest, I think we're doing pretty good. But
Yeah. So something else that I'm noticing here is you got some porous stuff, right? So we know about these bumps on the top and the cavities on the bottom that kind of look like hexagons.
it looks like there's a microstructure inside
But
of it.
yeah, it looks like there's a microcapillary structure kind of thing going on in certain parts of it on the sides there. And I kind of have to back way up and dim the flashlight a lot to be able to see different features.
This also has reflective elements on the surface. I think that's worth pointing out as well. So it tends to reflect kind of a pinkish and a turquoise, different microstructures. of
Yeah,
some
let's
kind.
see if we can get some better images of that. So, especially on the surface, but it all shows up on the side. I think I can scooch this closer and change the focus, and we might get a better shot of that.
Wow. Well, I would say try and get a couple of photos of the side. I don't.
So as I move the flashlight around, you see that orange reflection from the penny, right? That's probably not ideal. So if I can get this thing, I need a little mirror is what I need. And right here, you can kind of see these layerings here. Like they're kind of visible throughout, especially if I move this around so you don't see as much of the reflection. So you can see the reflection of the penny move on it. We have it on a penny right now just so that we can kind of use it as a size reference. But if I put it down on that black coffee cup handle, it will be a little easier to see. Let's do that actually. Now that we have our size reference. Kind of got to back it up a little bit to be able to get it fully in the shot. And now I might be able to actually see it from above and see some of that shiny structure that you were talking about.
I'm going to try and move it around.
There you go. I think I got it.
There we go. We're focusing it in.
So what I'd like to do is I'd like to try to get it focused actually here more on the top where it's
You know what? Can I adjust it a little bit?
it's better to adjust the microscope unless you're going to rotate it.
Yeah, I want to rotate it.
Oh, that was a good angle.
It has one side that's more flat.
That's good. That's good. Right there. Leave it there.
Yeah?
Yeah,
There
because
we
there's
go.
a slant on there. That we can kind of focus in on that slant, and I think that slant will show some of the structuring that I'm talking about.
Oh, sorry. See, I don't think you're going to be able to get it all in focus. because
Not with
it's-
this cap on it, no.
Here, let me try. Try that. Okay. Excuse me. There we go. That's a little bit more edge on.
That is an excellent angle.
Yeah, that should be the longest edge. It's interesting looking top down on this thing. It is fractured. Yeah, I mean, you said this is a hard, brittle material. It looks hard and brittle.
So right now I'm focused right where I want to be focused, which is not actually on the edge, right? We're not focused on the edge. Right now we're focused more on the top center area here. Because as I move the flashlight around there, we should see some of that fluorescence I'm talking about. Turn this down. So hopefully I can use the flashlight, especially from a distance.
Okay, so the coffee cup is definitely fluorescing.
Yeah. But we might have to flip it over. I think actually the dark side is a lot easier to see the different colored nanostructures.
You
I'll
can
do
do
it.
the honors of flipping it over.
I like to use 2 needles at the same time to have better.
So this is, you weighed this. This is a 7 milligram sample.
Correct. It's very light.
Yeah, and
we
it's also
think
very small. So there we go.
and we think that the glue on the end of it probably accounts for a good chunk of that weight. There we go. Oh, look at that structuring. You see this vertical column here?
Yeah. You want to try and get, you know what? Here, hold on just a sec. Hold on just a sec. Where's my... Where's my phone? There it is. Here. Because that's pretty bright. What if we tried...
We can control the brightness by controlling the distance.
Here. Try that for a second. Look at that.
Oh, I like the color of your light more.
Now, I don't know how long I can leave this on, but...
Oh my goodness. If you can leave it right there, I'm going to try to focus even just a little better on those nanostructures. And like, you see this pore here? That thing's huge. Can you bring your camera around and point it this way in more? You got an ant on your hand. Let me see your phone. I'm trying to light up that whole crack thing there. This dark area right here. There we go.
And you can see the layering inside as well. So there's definitely layering going on there.
It's all about getting those shadows just so.
See, now it almost looks like a, well, there's definitely a structure. It almost looks like a honeycomb.
Oh yeah, right here. It's kind of got a squished honeycomb to it.
But you can see there's definitely, yeah.
Let me give it a little more rotation so we can see this side back here.
Okay.
There's a little more edge on. Try holding it a little farther away from the sample. Look, there's another big old pore right over here. Oh yeah, move it back up. I want to see how you see these little fluoresters on top. I'm going to go to video for that.
Yeah, I was just going to suggest video.
Yeah, you can see these little spots there. Hold it a little farther away.
And you
All right,
can
you
actually
keep-
see the honeycomb structure there for a moment.
Keep doing it. I'm going to scooch it a little closer so we focus a little farther back on the sample where I'm seeing a lot of the light spots. There, you can kind of see one in the middle. Keep doing that. I'm going to move it again.
How tight can you go on the edge, on that leading edge, if you adjust your focus?
Right now I can get it pretty daggum tight.
Try that. See how tight you can focus in on that edge.
Oh, there's a nice red spot right there. Move your camera around. Yeah, okay.
Let me turn that just a bit.
Okay.
Try to focus in on that. There you go. Look at that.
Look at that
can we get it
obvious
in clo-
structuring on this very leading
Let's
edge
see
tip
if we
here.
can go even closer. Oops. There.
Problem is, as you get closer and closer, that lens kind of blocks the light from getting in there. Let's see if I can turn on this light. It's going to make a ring of lights around the sample, but it might be kind of helpful. We'll see.
Okay. Be real careful.
I can see it's right on there. Here's the light under here. That's not terrible.
Can I have your flashlight?
Maybe a little light from above.
You're getting video of it, right?
Yep,
So-
we're still videoing. I'm slowly zooming out so you can see farther and farther back on the sample.
Hold on.
I'll just zoom in a little bit at a time and you keep flashing the light around in circles. It seems like direct light isn't very good, but like if you can get the light on the edge of the coffee handle so it kind of reflects off the side.
Well, yeah, if you can zoom in, try and zoom in on the edge there. See if we can get really close on that edge.
I'll start on the right edge and slowly zoom in so we get towards the left edge and focus. Let's try turning up this light just a little more.
Yeah, we're hitting the light's hitting our telescope. That's the.
I really want to get those sparkles. Keep moving in circles. So I see a blue sparkle here and a red sparkle back there.
What if we tried 2 lenses on the telescope? You want to try that?
Sure, why don't we grab another one?
Okay, so let me try this. This is, what's this? This is an 8X. You have the tape? Okay.
Here's the tape.
And let me check this real quick. Yep, we're still recording. Okay. Yeah, that should do it. Because we know we have no shortage of light, so even if we lose a lot through 2 lenses, okay, and that's our 8X. This may not work.
It's going to give us a seriously small zoom area. And if it's off kilter at all, so the clicks for the detent to hold the thing are right here. So let's see how good we can get. I'll turn up that light all the way. Turn down the zoom all the way.
You might have to turn the light off.
Let's turn that on so I have something to look at. I'll zoom through the lenses. Go pretty deep. There's the second lens. Gotta zoom through that. Now I'm gonna have to get really close. Let's start with the penny. Let's use our control.
Yeah, so it does pick it up.
Oh, okay. We're getting something.
You know what? It's not going to work. Let's just take that second lens off.
Yeah, I think you're right.
It's okay. It was worth trying.
Let me turn this light off and see. Oh yeah. No light. I wonder if we have all the lights turned on.
You know what? Let's do this. Let's mount this up.
I'm gonna go see if all the light switches are flipped on. We've still been recording on the screen this whole time. That's pretty good.
So that's kind of back where it was.
Can I try the flashlight
I'd
first?
like to put it up higher.
I want to.
You know what? We could put it on this box.
Okay, so upper left-hand corner.
Hold on. This box is. up higher. It's not perfect, but it's something. You need to put some light on it. Okay, yeah. I think that's our sample right there. Look at that. How's that? And there's that honeycomb pattern. Okay, and now I bet if you come in from the side, oh wait, maybe that's worse, not better. Let's see. Okay, I don't know.
There we go. Now you can use the shadows to get it. See that? See those shadows?
Yeah.
And you can see all of those green iridescents in the near frame.
I'll be right back.
And right there you can kind of see a yellow in the nearest frame.
Okay. There we go. Yep, perfect.
Like, they look like tiny little gemstones.
Yeah, try and keep the light off the TV if you can. I notice it's reflecting into the TV. Okay, and I'm gonna sit down on this, I'll sit down in this chair. So,
Oh, right there you can see that blurry orange and blue in the dead center of the sample.
yeah. So again, that's the turquoise and the other, there are a couple of shimmer colors, I almost wonder if it's crystalline. And you can kind of see a pattern on top of it. And when we had that magnified, it really looked like a honeycomb.
We're kind of reaching the limit of.
Yeah.
So, oh man, there we got the little gemstones pretty well in focus here. We
Yeah.
got a pink, a yellow, a green, or an orange, a green, a lime green, a blue, green, and that red one, or that pink one. In these samples, we have some ruby, and ruby looks just like that pink color.
So it's difficult to tell if that's the native color of those little spheroids or if those are just microcrystals and the color is just based on their shape or size.
It might be, and I'm just now noticing this, let me move the mouse, it might be that some of these spherules like change colors depending on the angle of light, which would tell us a lot about their geometry.
Yeah. So the original Ars parts, if I remember correctly, somebody put it on a Van de Graaff generator and they claimed it jumped off. This would have been back in the 90s. We have not seen any kind of anomalous behavior that I'm aware of. It's just...
We haven't done much testing for anomalous behavior yet, except for seeing if it had any magnetic properties,
Yeah.
which it doesn't appear to.
So I don't know. We're not the best storytellers, but at least we're honest. That counts for
We
something.
may not be the best storytellers, but we're providing more angles and shots and evidence of this sample's oddity than anybody else to date ever has.
Yeah. Well, and again, the side-by-side that you did earlier, it looks, the structure and the layering and all of that is identical to Art's parts, except that, of course, this one is very, very tiny compared to that.
Now I'm starting to get some good angles here where you see a lot of the different colors seem to like follow a line. Right? You have all these different colors kind of bunched together, but it seems like some colors like fall in line with like colors.
So would you like me to rotate this around so we can get some different angles? Why don't I rotate our sample gently? How's that?
That's pretty good.
So the layer runs, the layering runs crosswise, but then the break points are up and down, which is interesting. They run completely across the layers. And we do have a laser too. How would that work?
Oh, the UV light, yeah.
Yeah, we do have a UV.
Now you can see all the edge of the glue really lights up.
You want me to try and rotate this thing around again? Let me do that. Oops.
There you go. I can move this.
Hang on just a sec.
There you go, we can get that in focus.
So I should mention for our viewing audience that we are at Falcon Space Labs, and this is a Falcon Space coffee cup. So if you're wondering what is it that this is, there you go. There's a little bit of UV. And it makes it harder to see that leading edge, doesn't it? Because it's so close. But
Let me see if I can get it from up underneath there with that UV.
I don't think there's enough space. Ooh, pretty. You know what? If I edge this right up to the edge, we could do it.
Let's try that.
Now you can come up from underneath.
You want to adjust the focus while I hold this?
Yeah, give me just a sec. Okay. Oh, you getting it?
I got it.
I could try to pull it back just a little bit too.
I'll have to refocus it. Maybe not. Oh yeah, that looks good.
It's hard to hold on just a sec. That's our.
Okay, well that just looks cool.
Yeah,
With the leading edge all pink.
We're just kind of goofing around.
And now at this point we're goofing around. Although, when you compare that fluorescence to, take off the light for a sec, to that fluorescence,
and see, you can see there is some kind of it looks like a honeycomb structure in there.
honeycomb structure, and there is some speckling here where you can kind of follow these paths of the gems. Oh, look at that, look at that. Oh, you can't see it with the light on.
Yeah, I was trying to.
But you see like this little lighted thing there? You see how it's sparkling like that? Mm-hmm. All them little sparkles. You know what that looks like? Well, it's happening up here too. That might just be our lens.
It could be. Yeah.
But it could also be residual fluorescing, like glow in the dark, you know, stores energy. I think it's just an artifact of the camera. Like some of these spots seem like they're retaining energy. Some of these spots up around here.
Well, what makes you think that? What's your indicator?
You see how they reflect like that? And they continue to reflect like that no matter what angle I put on them.
Do we have any other light sources we can use? Try different color lenses. What about this? Green. And
if you wanted to, Ooh. Oh, smart.
Yeah, I'm trying to get multiple colors.
That is some excellent diffusion. So we're not recording on the screen at the moment.
No, but the other camera is. And in a sec here, maybe we'll flip the sample around and. Here, so I did green. All the colors of
Oh,
the rainbow.
nice.
All the colors of the rainbow, see?
Smart thinking.
Oh, that was me. Sorry about that. I bumped the box. Yeah. And to be honest, we just probably want something white to go through for diffusion.
What about if we put some of this for white?
Try that. That's probably too light. That's gonna be too light.
If I fold it over a couple times?
No, maybe. Oh, here, try this. Here, try this. Try this.
Much better.
There you go. That's still kind of bright, isn't it?
Hold it back farther away. It's good diffuse light. Nice. Can you come in at all this way until we get the shadow? Yeah, there we go. Now I'll adjust the focus.
Should we flip that sample around?
Sure.
It's be careful because it's right on the
I
edge.
see that. Let me use 2 needles.
Yeah, you might want to push it back in a little more because that'll jump right off the edge. That's the shiny side. There you go. And then
This down just a little bit. And I'll fix the focus.
there, look at that. Look at that. Here, you do the light.
Some angles it's a lot easier to see that layering than others.
I'll be right back.
Right there is that 120 angle that I really think makes it look hexagonal.
There we go.
Yeah, the brighter side is a lot harder to see a lot of details other than these humps that are like bubbled hexagons. What would be really good would be if we could focus in on one of these crevices here and see if the structure changes at all in the slice
Do you
away.
think there's any way we could put a voltage on this?
Mark and I talked about it. We agreed not to do it yet.
Okay.
I want to test its capacitance, its inductance, its resistance. I want to test those things, but I don't think we have the proper test leads here to be able to do it.
Yeah.
My only suggestion that I had that we might be able to is if we use some metal foil and held 2 pieces of metal foil over it, but that is very tricky in and of itself because you need a really high quality LCR meter to do that, and we don't have that.
those. And then you just measure out the
Well, that's just it. How do you measure out and
do pin to pin and then subtract, right? I mean,
if you want to measure,
and that might damage it too. Those
that's exactly it. So we need to measure without damaging. So if we want to do it, you have to have 2 electrodes. Am I magnetic now?
You are magnetic.
Oh my gosh, no, it's the paper.
Oh.
So if you want to measure it, you have to have 2 pins with a gap between them and set the sample on top of them and then test the metal across it.
Here, so let's. You know what? I'm going to get the iPhone. I'll do that a little bit more. Oops, don't roll too much. Okay.
That's pretty good. Change the focus a little bit so we get that front leading edge a little more.
So again, if I remember right, and this goes to Gary Nolan analyzing the South American stuff, which may have been different, but he was saying he felt that it could have been faked here on Earth, but it would have cost millions of dollars to do it. For anybody who's like, are you sure that's extraterrestrial? No, it has no markings at all. So
It does not say made in Glorp.
yeah.
Although it might as well with some of the nanostructuring we're seeing.
Do you want to hand me the laser too, the UV one? Let me see if I can kind of get. Oh, it's the lens is getting in the way again.
I think I can back up the lens just a little bit and rezoom. We'll lose a little bit of the zoom, but we'll gain a lot more light.
Yeah, there you go.
Now I can make slight adjustments to the distance.
So I'm using the UV and the So you can really see that edge. It does look like there are some reflective areas there, doesn't it? Mm-hmm. But again, that could just be crystal structure. I don't know.
Did you try putting the UV light through the shot glass? I don't know how well that'll work, but it's worth a shot.
I don't think it's powerful enough.
Yeah, take the phone away altogether. It adds. It adds something. From an artistic standpoint, that greenish glow sure makes it seem more legit.
Well, if you want the greenish glow, put through the big flashlight, and then that'll really light it up. Ooh. Yeah. See, and then you do that, and you can kind of get.
Oh yeah.
Do you think you could hit the button for it, or?
Well, we're still recording, but let me take a picture of it
Oh,
instead.
is it recording?
Yeah.
Okay.
Go down.
Oops. What did we do?
There you go.
Oh, that's the problem. There we go. It's reflecting off the lens.
Well, let's get this lens a little more off-cantered. Oh, but that kind of blocks it. Let me back the lens up and refocus. Oh, it's reflecting off the metal of that. Let's move it closer to the outside edge of the handle.
Okay. Yeah, that works.
The other issue of being so close to the edge is that you get edge diffraction, but you know, it is what it is. Gotta get in closer.
I think you're too far away.
Yeah.
Yeah, it's
Now I can scooch this. And bend this. And as I scooch it, it'll move up. There you go. And I zoom in.
Hold on. Try and zoom.
Take that light away for a second. Let's use this to kind of get it focused.
I think we were doing better before, to be honest.
Yeah, I think this edge is not even enough.
Hold on, let me.